Imagine your best friend is having a wedding and has placed you in charge of arranging accommodation for all the guests. Since you want to provide the best possible experience, you decide to book some rooms in a 5-star hotel, very fancy. There's just one problem though. You happen to have a terrible memory and can only remember one room number at once, and you need to find a way to check all of the rooms on the wedding day for roll call. How would you do it? Well, one way could be to book consecutive rooms and remember the number of the first room as well as the number of rooms you booked. Then when it comes time to do roll call, you can simply start at the first room and move down until you've checked each room. In computer science, this type of data structure is known as an array, where each data element is stored directly next to each other in memory. To access a certain element, all you need is the address of the first element, as well as an array index, which tells you how far you need to move down. Arrays have their limitations though. For one, they are fixed in size, which means that you'll either waste memory if you have less data to store, or won't have enough memory if you have more data to store. Similarly, if some guests cancel or show up at the last minute, you'll either end up wasting money in spare rooms, or not have enough rooms for the unexpected guests. Therefore, another solution could be to book the rooms one by one as guests arrive at the hotel, and then give the room number of the previous guests to the guests about to check in. This way, you'll ensure that each guest has a room and no money is wasted. To access each room, all you need to do is go to the room of the last guest, and then ask them to give you the next room and repeat until you have successfully checked all of the rooms. This type of data structure is called a linked list, where elements are not necessarily stored next to each other in memory, but each element called a node contains both its data as well as the address of the next element in the list. While linked lists are dynamic in size, they also come with their own drawbacks. For example, linked lists take up more total space of memory since each node has to store both its data as well as an address. Nodes also cannot be accessed directly, which means that in order to access a specific element, you must start at the beginning and check each node until you find the one you want. Hopefully you learned something useful about arrays and linked lists, and can better decide which method you'll use when your best friend asks you to sort out accommodation for their wedding. Thanks for watching.